All right, let's jump right in. Today, we're talking about a pretty huge release from OpenAI called GPT-5.2-Codex. Now, this isn't just another AI model for coding. Nope, this one has a very high-stakes mission: defensive cybersecurity. So, let's break down what that really means. OpenAI is not holding back here. This single sentence right from their announcement tells you everything you need to know. They are positioning this as way more than just a simple code assistant. They're talking about a genuine partner for some of the most complex, most important work in the entire tech industry. So here's our game plan for today. We're going to start with what this new coding partner actually is. Then, we'll dive into the upgrades that make it so powerful. From there, we'll see it in action as a security analyst, which naturally leads to some big questions about power and responsibility, and we'll finish up by looking at how OpenAI is handling it with a defense-first rollout.
Okay, let's start at the very beginning. OpenAI keeps using this phrase, agentic coding model. What does that actually mean for the developers and engineers who are going to be using this thing?
The key phrase here, you got to remember, is agentic coding. This isn't about asking an AI to just, write one little function for you. We're talking about giving it complex, long-running tasks. Think big project refactors or building a whole new feature completely from scratch. Think of it less like a calculator and more like a really capable junior developer that can work right alongside you, day in and day out.
So, okay, it's a new kind of partner, but is it a better one? Let's look at the actual improvements that make this feel like a genuine leap forward for software engineers. And look, we've got the hard data to back that up. This chart shows how it performs on something called Terminal Bench 2.0, which is a really tough benchmark. It tests AI on real-world stuff, like can you actually compile the code you write? At 64% accuracy, GPT-5.2-Codex is setting a new state-of-the-art. It's clearly blowing past its older siblings. Now this is where things get really cool. This slide shows off one of its most powerful new tricks: vision. A developer can now just show the model a visual design mockup, like the image you see on the left, and the AI can look at it, understand it, and translate that picture directly into working code for a prototype. It literally sees the design and brings it to life. It's wild.
And beyond just vision, there's a whole bunch of upgrades under the hood. It's way better at handling those massive, messy jobs like refactoring a giant old codebase. It has a much better long context understanding, which means it won't get lost or forget what you're doing halfway through a long project. And hey, for all you developers on Windows, it's now a whole lot more effective and reliable.
Okay, so now let's see how all these new capabilities translate from just general coding into the super high-stakes world of cybersecurity. And we have a fantastic, real-world example that shows just how powerful this can be.
So get this story. A security engineer was using an earlier version of this very model just to study a vulnerability in React that people already knew about. As he was guiding the AI through a totally standard investigation, something completely unexpected happened. While the AI was just trying to reproduce the original bug, it started flagging all these weird behaviors, things that just shouldn't have been there. And that little thread led him to discover not one, not two, but 3 brand new critical vulnerabilities.
And here's the most important part. This isn't some theoretical exercise in a lab. This technology is already being used to find and fix major security holes in some of the world's most popular software, which makes the internet tangibly safer for all of us.
But of course, this incredible power immediately brings up a very serious question, one that people in this field call the dual-use dilemma.
This is the elephant in the room, isn't it? A tool that's powerful enough to be a security analyst's best friend could, in the wrong hands, become a malicious actor's most dangerous weapon. So how on earth do you manage that risk?
Well, the good news is OpenAI is tackling this head-on. Using their internal safety system, which they call the Preparedness Framework, they've officially classified this model as approaching a high level of cyber capability. They are already planning for future models that will, inevitably, cross that line.
So, knowing the risks, how are they actually rolling this thing out? Their entire strategy is built around one core idea: get the best tools to the defenders first.
Their first step isn't a public release. Instead, it's a trusted access pilot program. It's invite-only, and they're targeting carefully vetted security pros and organizations. The idea is to let the good guys, the defenders, use the most powerful versions of this model for ethical work, like finding vulnerabilities and stress testing systems, long before it becomes available to everyone.
And that preparedness framework we just mentioned, that's really the engine driving this whole strategy. It's their formal system for measuring risks, and it directly guides all these decisions on who gets access and when. It's all about building safety into the deployment process right from day one.
When you boil it all down, the entire strategy is about one thing: balance. The goal is to empower the defenders and give them an edge, to accelerate cyber defense across the board, while at the same time, very carefully managing and mitigating that inevitable risk of misuse.
And that really leaves us with the critical question for the future, doesn't it? GPT-5.2-Codex is a huge step forward, for sure, but it's just one step on a much longer road. As these AI models become exponentially more powerful, the central challenge is going to be this: how do we make sure the tools for defense always outpace the tools for offense?